And welcome back, classic boat friends, to this next exciting installment, part 8. In this section, we're going to cover a couple of things, pick up where we left off. We're going to cover the oil lines, how I did that, why I did that. We're also going to cover the oil pump drive assembly, and kind of some nuances of that, a little bit of that. But first, I wanted to just take a quick moment to thank everybody that's commented and helped along the way. It takes a village, and there's a ton of information to learn on this type of thing, and a lot of nuances with regards to older vintage engines, even though I don't really consider a small block Chevy older. But this and its application certainly is, going all the way back to 59 or so. But I wanted to say, I appreciate those that are following along to some of this detail work, and you certainly don't have to do things the way I'm doing them, but I'm hoping that you come away with just more knowledge about it. There's many different ways to do things, and this is just how I'm going about it. And I may be a bit or seem a bit anal retentive on some of this stuff, but my intent is to have a very good quality build addressing every single aspect of the motor, so that I don't have problems moving forward. And even in a perfect situation, it's a mechanical object, and there's potential for problems. And I'm certainly not above making a mistake or two along the way either. But anyway, just wanted to get that out of the way. One of the things too is that if you're not doing this yourself, maybe this is good, helpful stuff that you could guide a builder. And you could say, hey, builder, did you address XYZ? I got a feeling that a lot of times builders will not take this to this level of detail and this level of scrutiny. They're probably more likely to just throw used parts back into the engine and say, oh, well, you didn't pay me to rebuild this, when in fact, maybe they should have rebuilt it. Maybe it was worn out and they just didn't really care. So I'm hopefully helping people at least think through and guide and be upfront with a builder and say, this is the level of work I expect and I want to have done, and that's likely going to drive up costs. But in the long run, if you've got a great running, reliable motor, that's probably worth it in the end. And with that said, let's get to it. So let's talk about this remote oil filter unit. The original had copper lines and different type of fittings here. And I struggled to learn how to bend the copper lines, get the copper lines and the right bending tool. And I just fought it. And the originals looked pretty hacked. I mean, they had kinks in them, and I think it was not a great engineering deal for them to have done. So in the interest of taking a liberty and going for more reliability, ease of application, I decided to go with high pressure lines, which are compression type fittings that go into the pipe thread, 3/8 pipe thread here, and then a 3/8 high pressure line. This is a 350 PSI line, and these are push-on fittings, and they do not require a safety clamp here, but just for good measure, I think it was a good way to do it, because there is absolutely no way that hose is coming off there. And when it comes to your oil system, the last thing you want to do is spring a leak and dump all the oil in your bilge and burn up your motor. So these are so easy to do. Same process here. I use the high temperature thread, high performance thread sealant, Permatex. Put those in there. Of course, I checked them with with the tap first, pipe tap. Made sure it was gonna feel good and get in position the way I wanted. Put those fittings in there, screw these on and tighten them up, and then you literally push the hose on up to it. And then to do the clamp part, these are just these ring clamps. I don't know the exact terminologies for them, but it does take a special tool to do these clamps. And it's a little bit of an investment. I think this was probably 20 bucks or something, 20 or $25. But man, it is slick. I also used it for my PEX line to put in air all around my new shop. So this is a pretty handy tool and can be used in a number of different applications in plumbing and air and that kind of thing. Measured the lines, I came around here and got them all situated here underneath, everything tight, and you're good to go. And it literally like took 15 minutes. So you're gonna spend $100 in copper and a tubing bender and all this other stuff when you can make this, if you're not concerned about absolute originality, you can do it this way, and it's basically foolproof. There's no way things are gonna come off or spring a leak on that type of situation. Now, onto the distributor, goes in the hole of the regular small block Chevy distributor, but this is the oil pump drive gear, we'll call it that. And a couple of things about this. Obviously, it's a critical part. Not only does it drive your tack drive, but its primary function is to drive off the cam gear and turn the oil pump, just like the distributor would be. That on this situation is in the back of the engine, and this is in the front of the engine, which of course in a small block Chevy car, it's the opposite of that. This is really the back of the engine, housing wise. So a couple things about this. There's a bearing up in the top. There's a snap ring and a bearing in the top. You can replace the bearing. If you have, there's a thin shim between this drive gear and this housing. You can check for in play, just like you do on a distributor. This should have very little in play, and I don't remember, I think it's just like a couple thousandths at the most. But if it pops back and forth, up and down, you've got way too much in play. This gear is held on by a steel pin that drives right through the shaft on each side and then is kind of hammered over. And you can file that down and pop that out and replace it and take this all apart. Another critical area is there is a bushing in this end which gives you the side-to-side tolerance, and that can get very worn out. I had another one of these that you could literally just go tick, 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 tick. It was that loose, and you don't want to have that driving your oil pump, and you don't want to have any problems with having this thing shell on you and then you lose all oil pressure. So it's a good idea to really look at this very closely. You know, it's not an expensive bearing. You can pop that out. The bushing is available. I got one from Robert Hinkle, and he had several on the shelf. But it's the same bushing that's in the distributor. This is the same housing. The gear, just take a look at the teeth. Make sure everything, looks pretty good. It's not excessively worn, and that kind of thing. So obviously on the top of this is this piece here that goes on, and then normally you would see in a Chris Craft, you would see the right angle tack drive unit that would screw onto the top of that. There'd be a drive pin inside there that mates up with the top of this shaft. In the Riva situation here, well, in the early Rivas, they were using Stuart Warner instruments, and they used the exact same thing. They were running a cable up to the tack, and later when they went to the VDOs and they had electric tacks, they had a VDO sender, which is this application. So I managed to find a couple of the right VDO senders for my Riva gauges. So that goes on top, and then there's of course a new drive pin that's different than a Chris Craft tack cable. This has a big flat spade into it versus to crimped ends. And I'm going to put out a shout again for this stuff. This stuff is absolutely amazing, and here's why. This is that driven assembly gel, and it's a funky packaging. It's, you know, I don't know why they thought it would be good to put in a foil package, but this stuff does not drip or run away over time. And when you're putting your engine together, you may, like me, put it over the course of an entire year, especially if you're doing 2 of them. And you don't want your assembly lube, like this stuff, over time will kind of just liquefy a little bit and just maybe drip off. This stuff will not go anywhere, and it just goes on like a gel and it stays. So in this particular situation, I don't really know when I'm going to run this motor. So I'm going to use this on this gear so it meshes up with the cam, which I use this for the cam, so that I know that eventually when I get to braking and running this engine in, that I've got that lube is still sitting there versus this stuff here. They're just kind of night and day. This is still good stuff for some applications, but if you really want to go total peace of mind, this is totally worth it, in my opinion. So that wraps up this section. We're going to get on to installing this. Obviously, we lube this up, slide it down. Then the top part that holds it down, of course, is either like a solid piece of metal deal, or this wire mechanism here that you tighten down that holds the this unit in place, just like a distributor would. There's also, you want to have a little felt gasket that goes underneath here, so you don't get any oil seepage out from underneath that. That's pretty straightforward. So we'll come back on the next segment and address a couple more things, probably about close to getting to the carburetor. Okay, a lot to cover here on the carburetor front, and I'll try to do this in kind of a rational thought process, but there's quite a bit to cover, and this is a lot different than the original. So the original on the low-rise intake 283 versions was a Rochester 4-jet, and I chose not to use that because of several reasons. Number one, the reliance upon the old-fashioned heat choke. Number two, with this being blocked up to a 350, I don't believe, I'd have to do a lot of experimenting with jetting and different things like that. I don't believe that this original carb has the CFMs, the cubic foot per minute airflow, that really the 350 would need. And also just usability and that type of thing. Obviously, I'll keep them from an originality standpoint if I want to do something like that in the future. But my preferred choice is the more modern Edelbrock 1409 Marine carburetor, which I think is pretty good up to maybe like a 383 or maybe even a 400, something like that, before you go to the 1410 model from a CFM standpoint. I believe this is, gosh, I'd have to remember. This is either a 550 or a 600, maybe like a 600. You can check me on the stats. I don't remember off the top of my head. But a couple of things about this that I'll tackle right now. So I wanted the reliability, usability, functionable carburetor like a 1409 with an electric choke. But I want to maintain as much of the original look as possible. The main problem you run into this is the top of the carburetor, where the original Fisher flame arrestor fits, is pretty small diameter here. You can see that there. That fits like that. And it's a very low profile flame arrestor. That obviously does not fit on a Edelbrock 1409. So I've got a solution for that. And you could reach out to me in the comments if you're wanting to do something like this, and I'll see if I can help you out. But basically, I'll get back to that in just a second. So that's an issue if you want to kind of have that, maintain that look of the original flame arrestor, which I want to. Also, when we're talking about crankcase ventilation, when we go to a 350 block, the original crankcase ventilation was not great. A lot of people comment about that, and they basically had a kind of like a PCV valve in this port right here, which I've plugged. But basically, I want to do more of a conventional method of pulling a vacuum from the carburetor, pulling it through a PCV valve here, and then having it come out or pull through the other valve cover. So I have a little bit more of a closed system than the way the 283 did it. They originally did it. And so there's a slight modification you can do. It's very, very simple. I was a little intimidated about it until I actually did it, and it was super easy. But in the bottom of this carburetor here, and obviously this is the side, the back side, the front with the tag, and the idle needles is on this side. You want to tap this hole here, and you can put in a pipe fitting, a 3/8 fuel fitting here, and tap this material. It works out very, very easy. It's not hard to do. It allows you to tap into this hole on the bottom here, and this goes through there, and there's just a little thin wall. You just basically break through that thin wall, and then you run a tap into the case here and just thread it up a little bit, and then it'll go right in and you seal it. That part, this fitting right here, if you want to do this, is a Dorman 787018D, and I wrote that down here for you. Dorman 787-018D as in Delta, 1/8 inch MPT by 3H fuel line fitting. So you can do that modification, and then your carburetor's basically ready to go. So also, now remember, there's two different intake manifolds. There's the low-rise intake aluminum manifold, and then you see a lot of 283s with the standard higher rise manifold that's like cast iron. Most of the ones I've seen have a Carter carburetor, and all of the ones, I've never seen a Carter on a low-rise intake. I don't think that it actually fits. So two different carburetors, two different mounts. The only way you can get a 1409 to fit on this is with an adapter plate. And the adapter plate not only gets it to fit, but also raises it up slightly so that your linkages don't hit the intake. And another throw out to Eric Thearling for the guidance on this. He's done this before, and it's really slick, and you get the benefits of having a more modern carburetor. But I'm going to walk you through this process here. So I had already measured out my studs and know the height so that I don't have a whole bunch sticking up. And these are 1 3/4 inch. You could get away with 1 7/8 too, studs. Lay down a large open gasket. Then you have the adapter plate, just like a phenolic material. You lay that in there. And then you have your gasket with the 4 open holes. And then your carburetor is ready to go and sit on top of that. Now, there's only one adapter plate that you can get, and it's made by Transdap, and it's a number 2446. Transdap 2446. Why these are so ridiculously expensive, I have no idea. I don't know whether they're going to stop making these or what, but these were, I had to pay $75 a shot for them. It's ridiculous, but it's the only way to make this this carburetor go on there and work right. So I'm going to set this up on here. Okay, so that allows all your linkages to clear on both sides. And you got your electric choke over here. It's just a really, really slick setup here. And then what happened was I shout out to my brother, who is in the aircraft parts design business, and he CAD drew a special carbon fiber ring that will allow me to adapt to the flame arrestor, the original flame arrestor. So that goes on here, and it also has the fitting for the crankcase ventilation on it. So this will just sit right in here, and voila, I'll clean this up. Then you have the original look of the engine, just with a more modern carburetor. And that will end up looking exactly like this. So this engine is complete. And so here we have our crankcase ventilation. So we're drawing a vacuum as air is going down the carburetor. We're pulling a vacuum, pulling it through this valve, which means it's sucking from this side down this way. And then as I get together, put the carburetor together, this is just kind of an added thing here. This is basically a very, very fine fuel filter element that you can utilize, and I think it's really slick. Again, I'm taking a liberty here, but it's not the original carburetor anyway. It also comes with a fuel pressure gauge. Now you can just tap, you can put a plug in this, or you can actually use the gauge. I'm temporarily using it because when I do the run up and the start up, I want to monitor fuel pressure. And we'll talk about this a little bit more when we get to the fuel pump, but these carburetors don't tolerate high pressure fuel pumps. They really, I think the sweet spot for them is about 6 PSI. So you don't want to, you want to match up the right fuel pump. You don't want to have too much of a high pressure fuel pump with these carburetors. So this way I can monitor it when I'm doing the run in, and I can always just take this out and plug it. And I think that's it for now. Tighten the carb down and then work on the fittings and the tubes here in it, the crankcase ventilation. This works out really, really slick. And if somebody wants to get a hold of one of these, just reach out to me in the comments and I'll see if I can help you out. And for those that want to know, like for instance, this one I had a valve, PCV valve that's just a straight up part. Actually, I like the one that is a right angle. So this is the correct number for the right angle one. So you can see there, GM 193-13317. Just a nice clean look. That way you don't have to have your hose coming up and making a big arc. It just comes out, does that right at a 90-degree angle, comes right over to your fitting there. And then on the Summit part, this is the Summit number, G1523-2. Make sure, they make these for various carb types. The one you want has to match up to the fuel fitting right on the side of that carburetor on the 1409. So what you want is the G1523-2, which is the Carter Edelbrock number, which is a 5/8 by 20 fuel fitting. If you get the other one, it won't work. I promise you, I already made that mistake. So anyway, I think this is a really nice feature in it. It gives you your filter is a much finer micron filter up at the carb, so it's just kind of a good protection. Okay, let's talk about the fuel system, fuel pump filter. We talked about the Edelbrock 1409 being kind of a low pressure pump. You don't want a lot of pressure going to that. And this is the fuel pump of choice here that I'm using. It's a 1721 Edelbrock, and it produces 6 PSI with engines up to 600 horsepower. So should be just fine on that. It's a nice looking one too. But I want to talk about two things here. First thing you will notice is this is the bottom ports are fixed in this position. But what you will have to do is clock the bottom part of the fuel pump to your application. This one I clocked already, and basically I know which one's my inlet and outlet. And I've got my fittings ready to go for that. This pipe fitting with the barb on the other end, these 90s. And then I have the fittings for this fuel filter. We'll talk about that in a second. So you have to clock your, it doesn't come out of the box in the right position, at least for this application. So expect to clock it. Now the second thing you want to be very careful of is we're dealing with a marine engine, and if your fuel pump fails in a car, just, it dumps it down on the ground, or at least it used to. In a marine application, you want, if the diaphragm fails, you want to pump up into the carburetor. So this Edelbrock carb has a port that is easily punched out, and you can put this barb fitting in here, and I used JB Weld to slide that in there. It's really easy to do. It's not intimidating at all. Go to the industrial hardware store, get a fitting that will slightly a little bit larger than that hole. Very easy material to drill out. There's just a little bit of space in there that you can pop out, and then you're good to go. And then you've got your pump will vent gas if the diaphragm fails up into the carburetor, and we'll look at that in a second. On to the fuel pump push rod. I scratched my head and I did a lot of research on this, not only for these engines, but my previous two engines that I built up were big block Crusaders, and utilizing this same fuel pump. And I read a lot about the different push rods and the materials and so forth. At the end of the day, I ended up going and researching this particular one from Howard's. Now this is their composite, very lightweight, but it does not wear the same like a bronze tipped one. And this should be pretty much maintenance free and not have to worry about it. They are expensive compared to a regular one, but they seem to be amazing quality, and everything I read online about these and the way these are being used is this should be less maintenance, less something that you have to replace over time, and I think it's worth the money to have that peace of mind. Of course, we have our main back plate, gasket, and then our fuel pump plate with our corresponding screws. And then I want to talk about this original Chris Craft filter. It's a Bendix filter. Most people say, oh, this is junk and all that. I like the look of the engines, the nostalgic aesthetics of the engine, and I feel like I've been around these a long time. I feel like they work fine. They're not super fine. That's why I've got the other one up at the carb, but they're easy to refurbish, clean all out. You can clean this. I kind of call it like a movie reel filter here. You can clean all that out, and you can then get them all prepped. And one thing in the middle here is I've got a gasket right here that I replaced, and I found that at the industrial hardware store. Surprisingly enough, so you can just replace that gasket, put this thing together, and then you're back looking original with this fuel pump, fuel filter that mounts right on the back of the housing here, just like that. And then of course I've got the fittings. These are the pipe fittings and the barbs that go on that. Hopefully that will help. The procedure up in here, there's tons of videos on this, but follow a normal procedure to put your fuel pump rod up in there. I lube this up so it'll hold itself up in there. Just a quick tip is that if you're fighting this thing against the lever of the fuel pump, you're on the high side of the lobe, the cam lobe for your fuel pump. Just rotate the engine so you're on a low side of that cam lobe, and then this rod will go all the way up in there, and you don't have to fight it against your lever here on the fuel pump. And I'm going to use the gel on the end of this so that I know that it's not going to leak off or kind of run off over time. And then you should be good to go. Okay, fuel pump in. Nice clean installation. Got our fuel lines going on. This hose clamp from McMaster Car is again the Norma, and this works perfect. It's a perfect size for this 3/8 fuel tubing. And it is a 8 by 16, 8/16 clamp, and that is the perfect size for the fuel tubing. You don't get a lot extra coming out, and it works great. Also, here's the yellow fuel proof tubing that runs up to your carburetor from your fuel pump there, overflow, and that is a AAG00017. It's a 10-foot roll. You get this from McMaster Car. Okay, we're going to wrap up this series by doing a quick walk around here, or rather this part. We've got our dipstick installed. We just finished up with the fuel pump and the fuel lines. Got our dipstick installed with the original configuration. I put a little bit of RTV on this bolt because that does go down into the pan. I seat the dipstick. Originally there was just like this little tiny felt ring, and those are prone to just kind of overtime seeping. So I seated the dipstick in there with a little bit of RTV around the base just to seal it off. And we've got our dipstick and everything here working functionally. And let's go around to the back of the engine here. We can see we've got these new hoses put on. Again, that's with the 1627 clamp, works out perfect. Again, hoses you get from Robert Hinkle. Get a new setup for that. Transmission, we got those lines put on just as we did on the oil cooler, in the transmission cooler and on the side of the transmission here. So same kind of fittings, same kind of lines. This is a transmission linkage. This is unique to Riva. The way they kind of did things, they ran the cable back to the mount right here, and then over to a link that attached to this, so they could work that remotely. It's kind of a neat thing. Okay, as we walk around, everything is buttoned up with the carburetor. Again, I've got to polish this, but we talked about the base unit here that was custom made so that you could use the original flame arrestor to get that original look. Let's see here. Okay, so I've got my water pump installed, got my rubber hoses all connected here, so I'm pretty much done there. This is fresh water coming into the engine, and got to do some painting and detail work, but I've got my oil pressure gauge here. I am going to leave that. Again, not stock configuration, but this was a really nice oil-filled oil pressure gauge I found actually from a motorcycle shop, and it's just a nice small one there. And I'll get this VDO oil pressure cylinder painted up. I will, after I do the test run, I'm going to pull this kind of cheapish Summit fuel pressure gauge that comes with this unit here. I'll pull that and just put a I'll put a cap in the end there. That pretty much wraps it up. The last part here, well, we got our tags stamped. Again, a call out to Jim Stabe. Had reproduced the original Riva Special tags. Got those attached, all good there. And pretty much the last thing we do, which we're going to cover probably in a more lengthy video, is stabbing the distributor, setting it on Chris-Craft number 1 up there with my timing, and having it, we'll talk through a pre-run procedure on having everything just set up just perfect to where when you hit that button, you know it's going to fire, and you can bring it up quickly to the recommended RPM for cam break-in. So we'll see you on the next video.